My name's Trevor Moffat. I'm from the Improvement Service. I'm just here facilitating today's training session on NPF4 planning guidance on climate change, mitigation and adaptation. I'll just go through housekeeping today before passing over to our lead presenter, Charlie Nathan from Scottish Government.
Hello, everybody. Can't see any faces, I'm afraid, but good to have you along. Thanks for your time. Yeah, I'm Charlie Nathan. I work in Planning, Architecture and Regeneration Directorate within Scottish Government, and I lead on a couple of policies within National Planning Framework 4. And one of them is Climate Mitigation and Adaptation, which is Policy 2. And yeah, as Trevor's outlined, we've come to present on all there is on the guidance, and just wanted to take you through. So Trevor's done welcomes. So yeah, today's session, really kind of the aims for the day include sort of informal training and learning, sharing experiences and knowledge. So please do feel free to ask questions and discuss topics as they come along. Hopefully there will be a good bit of discussion. So as a brief summary of what we're going to cover, I'm going to go over a little bit of a brief overview really of the climate guidance that was published. It's been out now for about 3 months. I think it was beginning of June that it was published. I'll then pass over to our experts in the field of climate mitigation and adaptation, where they'll set out the sort of tools and resources that are available for integrating climate mitigation and adaptation into development proposals, development planning as well, and sort of trying to bring those concepts to life, really make them a bit more tangible, and not just talking about the jargon, but some practical demonstrations there. And then finally, we'll move on to the case studies, and hopefully a good bit of insight there about demonstrating that it is possible to do this sort of stuff in terms of mitigation and adaptation. We had intended to have some experiences shared by local authorities. Unfortunately, we've not been able to do that for this session. So I know obviously there are a lot of attendees today who do come from planning authorities across Scotland. So I'd welcome people chipping in on their experiences as things come to mind through the presentations, and then into the discussion we can pick those up. So my hope really is that by the end of the session, you can leave having built upon your existing knowledge of the climate space within planning, that you've gained some clarity on how this fits within the framework of NPF4, and have some tools and resources at your fingertips to explore as and when you need them. And I expect that there is a kind of wide range of experience and familiarity across the large number of attendees today, but I do hope there's something you can take away, something for everyone. So yeah, just moving on to the planning guidance itself, and a bit of scene setting. So in terms of why we've published the guidance, there's obviously the fact that NPF4 came about. There's new policy within there specifically on climate mitigation and adaptation, and through discussions both within the drafting of NPF4 and subsequently, you know, through the discussions and engagement we've been having with the planning community, it was a clear demand expressed for that guidance would be beneficial to help implementation of the policy. So it was set out in a delivery program that's regularly updated for NPF4, that we will be preparing this guidance. It has been prepared in-house, but it has also been informed by a whole suite of inputs, including the advice of a number of folk within the expert advisory group that was established specifically for the drafting of the guidance. And this included members, many of whom are speaking today, but also sort of heads of Planning Scotland, membership, Scottish Futures Trust, the Institute of Civil Engineers, key agency group members, including SEPA and Architecture and Design Scotland, also the Improvement Service, Verture, and the Institute of Environmental Management Assessment and RTPI Scotland were all on the group. For the climate mitigation element, looking at greenhouse gas emissions, we commissioned a piece of research to identify current tools, methods and approaches used in the development sector that has offered insight and a valuable resource in sort of demonstrating how greenhouse gas emissions can be factored into considerations for new development proposals. And finally, we also ran a consultation on the first draft of the guidance, which I'm sure a number of you here today contributed to. So I'd like to extend my thanks again to you for taking the time to do that and engage in the process. And the what for, I think, is fairly obvious in terms of supporting application practice of the policy. So a wee reminder of NPF4, what Policy 2 sets out. I mean, the policy intent itself is really to encourage, promote and facilitate development that minimises emissions and adapts to the current and future impacts of climate change. And that's really set out in the specific policy on development proposals themselves. And in terms of who's the target audience of the guidance, obviously it will be relevant in the main part to applicants, planning authorities and other decision makers, but I'd also add that it can cut across a number of other policy topics, especially where there are co-benefits to be realised, such as mitigation and adaptation benefits that can arise from integrating blue and green infrastructure. So in reality, the guidance could be of interest to a much wider spectrum of the planning community and the general public. I would note that the guidance does cover development planning and development proposals, so it is supplemented. It does supplement the existing local development planning guidance that was, I think, published back in 2023. So it does provide some additional information for integrating climate considerations into development plans, and obviously provides a fair bit of detail on the application for new developments. So I'm not going to go through this sort of line by line of the publication. It's there to be read at your leisure. But I did want to pick up on some of the key takeaways that may capture your interest and encourage you to look into it in a bit more detail, sort of following this session. So as I mentioned earlier, with regards to the research from last year, the guidance does regularly refer to and include best practice in the built environment sector, and our experts will be covering this practice in more detail in their presentations. Additionally, it's worth noting that the method and approach that is outlined has been adapted from existing practice and guidance to fit the specific needs of the Scottish planning system, especially in terms of the realities presented by different development types. The structures, as it is set out on the slide there, fairly straightforward. I would note that the core principles really are probably applicable across the board, not specifically for climate in terms of early engagement and the like, for planning applications and really scoping out what kind of information requirements there are to support decision making. And there's the link when the presentation is circulated. The link's there for you to access the guidance. Excuse me. So here are kind of four, I suppose, pointers to what it includes that might draw your attention. Definitions are in there around terminology and concepts that are used, particularly around greenhouse gas emissions and assessments, things like embodied carbon, what does it mean, and how do you consider it? But also from the adaptation perspective in terms of understanding climate and the risks presented by a changing climate and what that might look like into the future and how you consider that. It also supports a proportionate approach, which I think is quite important, that it is sympathetic to the varying circumstances of each individual proposal that may come forward, and it creates the space for flexibility in the system to ensure that the type and quantity of information is adequate to support decision making, and that we're not going into this overly complex, making an industry out of this, the requirements here. But also it has, should you want to use it, it has a step-by-step sort of guided approach, and it includes reporting templates that offer prompts to folks so that they, prompt us in terms of the type of information you want to be providing to support decision making around climate, and it obviously has the pointers and the references to a whole suite of resources and best practice. So the next two parts really cover the tools, resources, and practical application. So I won't go into those details because that's going to be following in the presentations. And just in terms of looking at what I hope it delivers really in terms of this guidance and maybe future iterations should they be forthcoming. It's providing a good resource for best practice. It's providing that flexibility and proportionate approach to ensure it's not overly complex and burdensome. But at the same time, it does provide an opportunity for consistency of approach across the regions, across Scotland. And in terms of thinking about the next steps, it's really be good to hear your experiences, not just today, but feeding those in and any issues that you may come across and then queries. Certainly we'd be all ears to hear those. So please do get in touch with that as this progresses and the guidance may be implemented in decision making as we go forward. And this is just a bit of a reminder as to why we're all here talking about this subject. And that's me, I think, on that. So
if I'm going too fast, you can always replay it later on. I'm going to get a couple of caveats out the way. I will provide a couple of opinions during this 15 minutes. They are not necessarily those of the Scottish Government, WSP, or the Institution of Civil Engineers, although I think that we're all pretty aligned on this. What I'm about to show you is focusing on the carbon part, the climate change mitigation, decarbonisation, the carbon parts of the guidance. And I just want to say a couple of things up front. This isn't new. So if some of you are not aware of what I'm about to be discussing, this isn't new. This has been around for years, over a decade, more than that, in fact. It is just good practice. So this is an opportunity for us all just to sort of raise the bar up a little bit to where it ought to be. And I think it's great. It's kind of overdue, if I'm honest, but here we are. We're here now, so that's good. Right. Carbon in the planning process is becoming increasingly important, increasingly in the public eye. We have 2 or 3 years ago a successful objection to Heathrow's third runway on the grounds of climate, because the planning process didn't account for the Paris Agreement. That's a whole story in itself. Also, more recently, last year, we had the Finch case where a developer wanted to extract oil, and the planning proposal was turned down eventually at the Supreme Court because the developer hadn't taken into account what they referred to as downstream emissions. In simple terms, for now, basically they didn't take into account life cycle greenhouse gas emissions, the overall carbon emissions impact. So this is the theme. Whole life carbon emissions must be considered, and I'll explain what whole life carbon emissions are. On the screen now, you will see something that at first glance is quite daunting and confusing, right? But in essence, this is the whole life carbon picture. It is contained within various engineering, design, climate-related standards. They're international standards, and it comprises 4 key parts, A, B, C, D. A is all the carbon emitted in the creation and preparation of the development. So think of A up to the point of cutting the ribbon and the opening ceremony of the development. B is the entire use stage, the operational stage, likely to be decades for many developments. Could be 60 years plus for a building, could be towards 100 years for a road. It's all that carbon that's emitted during that phase. C is end of life, so any decommissioning, breaking it up, dismantling, disposal, that sort of thing. C, without needing to go down a rabbit hole, is unlikely to be a major concern for carbon, because C, by the time that occurs, it's going to be decades beyond 2045, so decades beyond the time at which we should be at net zero anyway. So C is unlikely to be a serious carbon aspect. Still, we need to consider waste and circularity. That's a different thing. And D, think of as knock-on side effects from the development. So not so much direct carbon emissions, but indirect. So is your development going to lead to a knock-on effect that creates an increase in vehicle kilometres in Scotland? Is it going to lead to an increased uptake of solar panels going the other way? So think of D as influence and A, B, C as control. And the themes of control and influence stem from PAS 2080, which I'll mention soon, but they're also very much part of this guidance. And whole life carbon emissions impact is the overall change in carbon emissions over time, or more specifically, the appraisal period, which is going to be decades. So just think about it like that. We are interested in, we must consider the overall change in carbon over decades, which again, to the uninitiated might sound quite scary and daunting, but like I say, this is happening all the time. This is normal practice. Right, NPF4 itself, policy 2A, this is the one I'm particularly looking at. Development proposals will be cited and designed to minimise life cycle greenhouse gas emissions as far as possible. What are life cycle greenhouse gas emissions? That's whole life carbon. It's just a slightly confusing, sort of slightly different terminology, but it's the same thing. When I say carbon, just think it's an equivalent word for all greenhouse gas emissions, and life cycle is the overall lifetime of the asset. And NPF4 seeks to ensure that whole life carbon is considered through the planning process. So you'll hear some information about EIA, I'm sure, very shortly. Environmental impact assessment doesn't apply to all projects. This applies to all developments, which is why this has to be proportionate. Okay, you're not going to be going down deep, complicated quantitative carbon assessments for a small shed extension. This is proportionate. I mentioned PAS 2080. The guidance, I think, it's a good compromise, because it doesn't say thou shalt follow PAS 2080, but it points towards PAS 2080 as an appropriate, good practice standard for managing whole life carbon in the built environment, which it is. So it promotes reduced carbon, increased value delivery, more collaborative ways of working, and a culture of challenging convention and traditional practice for decarbonisation. And more and more, we're seeing PAS 2080 mandated by all sorts of different asset managers and government organisations. So just to recap, this isn't mandatory in NPF4, but the way I look at it, if anyone's coming to you with a development that really requires a carbon assessment and they haven't followed this or the principles within it, they have to have a blooming good reason. And I can't imagine what that reason is right now. So onto the NPF4 itself, what we're talking about today was informed by research we did last year. Again, that's available on the SG website. There's a QR code there. You can just sort of Google it and find it. That's really worth the look if you want to understand the sort of backdrop to all of this. So what's going on? What standards are there internationally? How are people calculating carbon? What's the general trajectory in this area? And the way we looked at that piece of work was not picking out perfect examples of how to calculate carbon to the nth degree, but just how are people realistically and pragmatically doing it at the moment, to be able to show that this is possible, and to ask for it in this new guidance isn't unreasonable. So this is the guidance itself. I'm just going to pick out a few things about it. Explains what whole life carbon is, explains why that's life cycle greenhouse gas emissions. That's the overall piece, the whole picture. It's aligned with PAS 2080. And those of you on the call who are involved in the city and regional growth deals, the Scottish city and regional growth deals, you're probably familiar with this already. In fact, if you're following the city and regional growth deals carbon guidance, you will be laughing when it comes to all of this, because that, foreshadowed all of this. It's proportionate. There's a section 4.3, I believe it is, which sort of indicates that it may be unlikely that you would need to do a carbon assessment for instance, residential dwellings with less than 10 dwellings, or less than, I think it's 1,000 meters squared. And understandably, the guidance is precautionary, and it's not absolutely definitive, but it says things is unlikely, and ultimately it's in the judgment of the local authority as to what you require. Continuous improvement is well in there. You know, we'll learn a lot from this. As Charlie said at the beginning, I'm sure you will encounter some interesting conversations, I'm sure, with developers over the next few months who may be pushing back on certain things, who may be really doing brilliantly. So I'd really encourage you to talk to each other and keep that community going to help to share best practice and normalize this. Okay, so on to carbon sources, or like sources of information here. I think the great thing about this is, and we couldn't really say this 5 years ago, everything I'm about to show you here is free, freely available. And with this information that I'll summarize shortly, you can calculate pretty much anything, okay? You might want to get a more sophisticated tool depending on the sophistication of the project, but if you had to, you could calculate the carbon from just about any development using these sources. There's PAS 2080 at the top. There's hyperlinks to all of these things. The Built Environment Carbon Database was issued, I think, just about 2 years ago. It's improving all the time. A free, publicly accessible database, tens of thousands of environmental product declarations, and an asset library, so you can go in and have a look at these things. Very, very good. Inventory of carbon and energy, similarly, free database of embodied carbon factors, regularly updated. If you really want to get into this and say, well, how do I learn more about it, and what is the really best practice? What should I be insisting is followed? It's the Royal Institution of Chartered Surveyors, RICS, Whole Life Carbon Professional Statement. That's what it's called, right? And that's the global standard for whole life carbon measurement. That doesn't necessarily tell you how to reduce it, but if you want to be absolutely clear about how we're accounting for carbon, it's the RICS Whole Life Carbon Assessment. And the last one there is for operational energy. So if you're looking for electricity factors, fuel factors, that sort of thing, the UK government updates this annually, and that's your go-to data source. The essence of this is like a tiered approach for all of these things. You start off with generic values that are contained within these kind of databases, and then if you know specifically what kind of concrete you're using, or specifically what kind of steel you're using, then you can get a more specific carbon factor. So the last couple of slides, I'm just going to show you very crudely how this works for embodied carbon. Bear in mind, this is a very simplified procedure. And I'm trying to put myself in the shoes of someone that really doesn't know anything about this, has been told they need to calculate life cycle greenhouse gas emissions. Where do you start, right? So A1 to A3 is, if you remember that table earlier on with A, B, C, D, A1 to A3, that's product stage carbon emissions. So it's all the carbon that's been emitted in the creation of a product. So A1 is the quarrying and original extraction. 2 is the transport of that source material to manufacturing points. And 3 is the manufacturing process itself. And that embodied carbon A1 to 3 is estimated for loads of different things. It's much more specific for specific products. But here's the general process. In your project, identify the key materials being used, the hotspots. You know, without going into detail, you're looking for the key issues, the key things. For instance, your main construction materials like concrete, steel, timber, asphalt, bitumen, that sort of stuff. And if you don't have a bill of quantities, which is a list of all the things that you're going to be using on the site, then you can use broad estimates at the beginning. That's another thing that's accepted in this kind of carbon accounting world. The earlier you're doing this, the rougher the number's going to be. But that's okay, because the earlier you do it, the more likely you will be able to make a difference. The later you leave it, the less opportunity you have to change things. So let's say you've got your full list of all the materials that are going to be used, or at least the highlight key things that contribute most to your carbon emissions. Then you need to find carbon factors. So you need to use an appropriately authoritative database, such as the ones I just mentioned, these are the ones that are mentioned in the guidance. Recognized database. Ensure the factors are in the appropriate units. Maybe don't worry too much about what's on the screen there, but generally speaking, we're looking at weight or mass of the thing, whatever the thing is, and then you'll have an amount of carbon per mass of that thing. So kilograms carbon per kilogram of a certain type of concrete. You'll see what I mean in a minute. You multiply these things together using Excel probably, or I said use a tool. So various tools are around, various commercial tools, some free tools, but ultimately, usually it boils down to a spreadsheet and you're pulling it all together in a spreadsheet. Do the calculations. This is just the embodied carbon then. Remember, this is just like the product carbon. Then you've got to take into account shifting it to the site. So you incorporate transport. There's guidance on that too. Pull all that together. So A4 is the movement of material to the site. And A5 is the construction process itself. So again, there's more guidance on this, but I'll show you an example in a moment. And for clarity, a reminder, it's the RICS carbon assessment methodology that's the real Bible on this. That's the thing, if you're ever uncertain about it, like, how do we do this? It's the RICS. How would RICS say that we do this? So here's a real simple one, final slide. I'll put them all up in one go. Okay, so let's look at the top one. And these are totally random numbers off the top of my head, these quantities. Let's say you've got 500 meters cubed of concrete. What's the embodied carbon of that? Well, you have to know what type of concrete is. There's different types of concrete, different concrete strengths, different cement mixes, all sorts of things, right? But if it's an early stage, you would be precautionary about it. You wouldn't assume it's some ultra low carbon concrete. What's pretty normal concrete? So I've looked at the ISE database. Again, well, this is free. And the first thing you have to do for that meters cubed is convert it into tons. So there's a recommended density of 2.4 tons per meter cubed in that ISE database. So you multiply 500 by 2.4 to get tons of concrete. And you times that result by 0.0871, which is the carbon factor that's in the ICE database for that type of concrete. Okay, and then you'd get your 104 tons. Steel, that's a bit of an easier calculation because you don't have to convert the units. It's just 100 tons, assuming the carbon factor for steel bar and rod reinforcement. That's 1.72 tons of carbon per ton of steel. So you make that multiplication, that's 172 tons. Similarly, asphalt, same idea. Find an appropriate proxy in the database, do the multiplication, there you go, and then you add up all those embodied carbon bits and pieces, and then you have a total. Then you would incorporate your transport on top of that and other bits and pieces, which I think, maybe I've been doing this for too long, I think the other bits and pieces are easier. This is the bit that you need to get your head around and takes a little bit of understanding, but hopefully I can reassure you now that this is not rocket science, to use a terrible cliche. People have been doing this all the time. The databases exist now for free. So final point, I'm sure questions will come up, is whenever you can estimate cost, you can estimate carbon. Okay, that's so important, I'll say it again. Whenever you can estimate cost, you can estimate carbon. So if you've got someone coming to you saying, I've got no idea what the life cycle of greenhouse gas emissions is. I've got no idea what the embodied carbon is. I can't do that. It's too early stage. It's too complicated. But I know how much it's going to cost. Well, it's the same thing. The cost comes from the quantities of materials, the types of materials, the sort of activities they're going to be doing. Carbon comes from exactly the same place. So there's a very strong carbon and cost correlation, and all that database information exists already. So that's it for now.
As Charlie mentioned, I'm the Programme Director for the Adaptation Scotland programme. It's funded by the Scottish Government and supports public bodies, community organisations, private sector organisations and individuals to understand the impacts of climate change and take collaborative and effective action. And we've been supporting as part of the expert group to inform the new guidance that's been developed. So I'm going to focus today on the adaptation part of the guidance, but also look at where it can align with some of the mitigation work that Lewis just talked about there as well. So just to make sure that we're all clear on what we're talking about here, just going through very briefly some quick definitions. So climate resilience is that ability to anticipate, prepare for and respond to climate hazards and climate vulnerabilities, whether that's within a particular place or among different social groups. Adaptation is all the different types of actions and solutions that at various scales can be implemented to build more resilient societies and economies and respond to the impacts of climate change both now and those that we will experience in the future as well. So we're now going to look at what those climate change impacts are, those that we've already observed, and what we might see in the future as well. So I think it's worth reiterating, as Charlie showed on the slide earlier, that the climate stripes that many of you will be aware of that trend of a warming world, and particularly here in Scotland as well, and then the impacts that that can have on our economy, our place, our livelihoods, our areas of work, and indeed on our built environment as well. Scotland's 10 warmest years have all occurred since 1997, and we've already seen record warming over recent years as well, with the warmest year on record in Scotland in 2022, and we've gone on to experience a series of heat waves since then as well, mainly just this summer, for example. However, despite that warming trend and those increased summer temperatures, we've also seen an increase in rainfall, particularly during the winter. So over the last decade, we've seen almost 30% more winter rainfall than we did during this period between 1960 and 1990. So that's a huge amount of additional rainfall that we're having to deal with every winter, and so we need to make sure that our built environment, our land use and other practices are responding to that already observed change in rainfall in the winter with more extreme rainfall events. Elsewhere in our coastal areas, we're starting to see sea level rise rapidly increasing, and the rate of sea level rise has almost tripled over the last 25 years and continues to accelerate. And in some places across Scotland, we might see up to 30 centimetres of sea level rise over the coming decades. That poses significant challenges and risks to coastal communities, particularly across the east coast of Scotland, where there is more soft erodible coast as well. So our planning and decision making needs to take this more gradual but very serious change into account. We've also started to see increased instances of storminess and extreme weather. And over the last decade, since the Storm Naming Convention began, Scotland has been impacted by more than 60 named storms already. So it's a significant amount that we're having to ensure that we are better prepared for. And we know that in the coming years, we're going to see an increased prevalence of those as well. So we need to be prepared not just for what we've already experienced, but the increased frequency and intensity of that type of storm in the future as well. So what will the future look like in Scotland's changing climate? We know that the changes we've already experienced are projected to continue and intensify with higher average temperatures, warmer and drier summers. So we've seen recently the alerts from SEPA and also from Scottish Water about drought incidences across Scotland, and that's going to become an increasing challenge, particularly across the borders and across the northeast of Scotland as well. We're also going to see those milder and much wetter winters with more intense heavy rainfall events as well. So we need to ensure that our planning and our decision making take all these factors into account, both the climate challenges that are being posed right now and how they might evolve in the future as well. We also need to ensure that we think about spatial planning and the wider range of climate risks and how they might present themselves in different ways across a place. And this was highlighted in a recent Climate Change Committee report to the Scottish Government as well. What you can see on screen here is a screenshot taken from a map that Verture supported to develop through the Climate Ready Clyde Regional Adaptation Partnership, and it brings together a range of data layers across the whole of the Glasgow City region, looking at both heat stress in particular localities, exposure to flood risk, as well as the socioeconomic dimension as well. So the darker little blue lines that you can see in each neighbourhood area also indicate those areas in the 20% deprivation level within the Scottish Multiple Index of Deprivation as well. So it helps you to tools like this can help you to understand that interplay between climate risk and social vulnerability as well, which is also very critical to think about when looking at planning, decision making and applications. But responding to climate change and its impacts within the planning context is not its own silo. It's not entirely separate from the kind of things that Lewis was presenting about just a few moments ago. And I think this diagram really helps us to think about that, those synergies between adaptation action and mitigation action as well. So while there might be some specific actions and that might include sort of building adaptations as well that are primarily designed for responding to some of those climate risks, or others that might be primarily designed for helping us to reduce the carbon emissions from or the greenhouse gas emissions from developments. There are many actions and interventions which can also help to achieve multiple outcomes, both for climate adaptation and mitigation, as well as a wider range of other things covered in the National Planning Framework, particularly in relation to things like biodiversity and nature connectivity as well. So when we're thinking about the design and siting and development of new developments, thinking about how different measures, different designs, different ways of siting things and different materials that might be used can help us to achieve multiple benefits is really, really critical to that approach. As you'll see from the guidance that's developed, local development plans and the evidence within them are really central to how we approach the adaptation and mitigation part of the National Planning Framework. Local development plans should support adaptation to the current and future impacts of climate change by taking into account climate risks, guiding development away from vulnerable areas, and enabling places to adapt to those risks. So gathering information and evidence on the extent of climate impacts on a region or a local area, both now and in the future, and how this may change is really, really important to ensure that today's developments will continue to work as well while the climate changes, enable the identification of adaptation measures and solutions that are applicable to a particular development and area, and also to help ensure that the current and future impacts of climate change are taken into account, and ensuring that the development is designed to be able to adapt over the long term as well. So to do that, we need to develop a baseline evidence of data as well as an understanding of how things may change in the future. So that can include our observed climate trends and projections, so the summary of which I just presented earlier, and I will go through some of the sources of information of where you can find that both for regions within Scotland as well as specific localities. To then look at what climate risks and impacts those trends may pose to a particular development, while also considering how our climate is going to change in the future, both across Scotland and within a particular locality as well. Again, I'm going to touch on some of the sources of evidence and information you may use for that as well. So what are the impacts of climate change in Scotland? I've summarised some of them here. This comes from a resource available on the Adaptation Scotland website. With underneath each of these, there is a much more detail and links to other information sources, case studies, and areas of information as well. But we can see here that there are quite a wide range of impacts that we are already facing and those that we're going to face in even greater intensity and frequency in the future as well. Whether that's coastal erosion, the health of our natural environment, thinking about human health and well-being, damage to buildings, as well as things like infrastructure resilience as well, and how we think about our cultural heritage and land use too. So we need to ensure that we consider all the different types of impacts from climate change in a place and to a particular development when we're thinking about the decision making around the design, siting, and approval of such developments. So where can you find out the most relevant information to help you support this and look at that at a particular local level as well? I've summarised a few of them here, but there are many more detailed in the annex to the guidance, which Charlie shared the link for earlier as well. So I would encourage everyone to look at the wide range of information sources that are available there. But I'll just highlight a few here. So the first is from the Met Office. So the Met Office's Local Authority Climate Service is a fantastic tool to be able to look in a very granular way in a specific locality about both the observed and projected trends and projections of climate change in that area. And it provides the most robust, detailed and up-to-date evidence of those observed and future climate changes and being able to focus that on a particular locality. Dynamic Coast is a partnership in Scotland that is looking at new approaches to the modelling of sea level change and coastal erosion across Scotland as well. So for developments in coastal areas, it's really important that that you explore how our coast is changing and how sea level rise and other issues and the change in storminess and when those storms are happening, so for example around more spring tides, which can create greater issues, are being considered and factored in to ensure that we don't lead to developments in particularly vulnerable areas across our coast as well, and that we can adapt to that changing coastal environment. The local authority, the local climate adaptation tool is another tool similar to the local authority climate service, but which goes into a little bit more detail, particularly around health and well-being. So it's a very useful tool to drill into some more of the detail than is available through the Met Office, drawing in a wider range of socio-economic considerations and factors into the tool as well. And finally, a little bit of a plug for my own programme, the Adaptation Scotland programme. If you go on to adaptation.scot on the website, you'll see a huge range there of resources, information sources, guidance, case studies, networks that you can join, and other things such as regional partnerships, which I'll touch on in a moment as well. So that is kind of the one-stop shop really for all kinds of adaptation information relevant to Scotland. So hopefully from there you should be able to find everything that you would need to inform your planning, decision making and development. Also, we have something called regional adaptation partnerships. So this is a concept that the Adaptation Scotland programme have supported over many years to bring together different types of partners across a region, recognising that no one individual group or person or organisation has all the tools, resources for decision making at their disposal to be able to adapt effectively to the impacts of climate change, but that it requires collaboration across sectors and across a place. So the first of those was with Climate Ready Clyde across the Glasgow City region, bringing together 8 local authorities, 3 universities, the local health board, the Strathclyde Partnership for Transport, and other public bodies, as well as things like the Chamber of Commerce, to explore a wide range of regional adaptation actions. But as part of that, we've also then been undertaking regional climate risk and opportunity assessments. So these are really, really detailed analyses of the climate risks that are being posed in a particular region, but also the range of options and actions that are available to adapt to those impacts of climate change as well. Since then, in the Scottish National Adaptation Plan that was published in September last year, there is now a commitment from the Scottish Government to expand regional adaptation partnerships to cover the whole of Scotland by 2029. So we now have partnerships established in the Highland region, across Tayside, and across South East Scotland as well, with emerging partnerships in the Outer Hebrides and a few other areas that are just getting started now as well. So again, through the Adaptation Scotland website, you will be able to find links to all of the regional adaptation partnerships and all of the different types of regional climate risk and opportunity assessments that have been conducted, that will also be able to provide greater level of information in your planning decision making. So focusing a little bit more on the content of the guidance within the new guidance published for Policy 2 in NPF4, there are sort of 5 key areas to the adaptation section. First of all is the proportionate approach, which Charlie highlighted earlier. So recognising that there are a wide range of developments that this will cover, from very small ones to very large and wide-scale ones as well. So we need an approach which can kind of expand or contract relevant to the scale and size of that development and the level of information that is required as well. So hopefully the guidance sets out the level, a clear understanding of the level of information that is required for each of those different types of development. The next is siting. So it's really, really critical that we consider the siting of developments, both new and existing, when looking at planning and decision making, to ensure that we're not developing in areas that are particularly vulnerable to climate impacts, particularly things such as extreme flooding or overheating, for example, in urban areas as well. So there isn't within in this guidance a clear distinction to say you cannot develop when there are these certain parameters, but there's clear information and guidance of the types of information you would need to consider in relation to some of those climate risks. Similarly, with the design of developments as well, we need to ensure that both the design and the materials used are going to be appropriate in both our current and our future climate as well, particularly if we're thinking about our built environment, where new buildings may, hopefully be designed to last for many decades to come. Throughout their life cycle, our climate is going to change. Even if we reach net zero tomorrow globally, we're still going to see many years of climate impacts because of the existing emissions that we've already put into the atmosphere. So ensuring that the design of buildings can respond to those changing climates, whether it's about improved shading, for example, to reduce overheating, or thinking about designs which can minimize the risk of flooding, to basement areas, for example, is going to be really critical. Similarly, we need to also think about the adaptability of planning and design as well. So while there may not be a really strong case right now for significant investment in designs which can respond to extreme heat, for example, but we know that this is an area that may be likely to be exposed to that in the future, or similarly around flood risk as well. If the flood risk currently is maybe medium or low, but we know it's an area that may be more exposed to flood risk in the future when we experience increased wetter winters, for example, there may then be points at an appropriate time when a specific component of a development is due for maintenance or upgrade, or when a specific threshold threshold has been reached that triggers the need for a measure. So this is known as an adaptation pathways approach. And again, there's a little bit more detail and guidance on the types of information sources you might want to use to consider that in the future as well. But it's really about that link between the design to ensure that those adaptations in the future can be made in a cost-effective way. So just finally, I wanted to touch on because I'm conscious of time, touch on a case study. So this is an example from the Dunfermline Learning Campus as part of Fife College. So this is something that the Adaptation Scotland programme supported a couple of years ago. The campus was already approved and partway through its build actually, but it was part of the public buildings net zero standard. It's kind of one of the pilot initiatives for that to explore the use of that public net zero building standard. And one of the components of that is around climate adaptation. And this was the sort of the pathfinder for that principle. So the Adaptation Scotland programme used tools such as the Changing Climate for Development guidance, which is on the adaptation website, to assess the climate resilience of the new campus and explore the climate-driven hazards during the construction phase, as well as during the use phase of the building as well as using other toolkits that are available on the Adaptation Scotland website, like the Climate Hazards in the Workplace Toolkit. So we explored both the recent and projected changes to the climate in the Fife area, and knowing how those climate-driven hazards would likely impact on the structure and use of the new campus. So we also then supported the participants in the workshop. So that included the main contractors, the clients in terms of Fife College, as well as many of the other teams that were involved in the development, design and use of the building, including student groups as well, to jointly identify potential adaptation actions and to prioritise those that could be implemented at that stage of construction. However, we did also then put together some guidance on how some of those factors could be better considered earlier on in the process, ideally at the stage of application as well. So again, if you go to the adaptation.scot website, you'll find much more detail on this and some of those resources as well. So that's all from me. Just a reminder there of where you might find a little bit more information on that and how you can get in touch with us as well. Thanks.
Thank you, and morning everybody. Again, this is going to be a bit of a whistle stop tour. Conscious you've also had quite a bit of information thrown at you, but the aim is to just kind of highlight some of the key points and some pointers as to where you can look for further information. And again, hopefully a little bit of reassurance that what we're trying to do is practical, it's proportionate, and although the guidance is new, the consideration of climate change for the bigger development projects certainly shouldn't be. For those that don't recognise this image, this is the Edinburgh Bioquarter project, and I picked it because colleagues here at LUC are involved in the master plan for this. It's a new mixed-use development, and I believe it might soon be progressing to EIA. So I'm pretty briefly, but I'm going to talk myself about both climate change adaptation and mitigation, particularly in terms of how it's covered in EIA. And I've put there emissions reduction in brackets after mitigation, because the term mitigation is a bit confusing for EIA practitioners such as myself, because when we tend to think about EIA mitigation, if we think of something such as flood defence works, we see that might be that's mitigation to address climate change adaptation to flooding. It's not climate change mitigation as such. So to avoid complication, we often talk about climate change adaptation and we talk about emissions reduction. So I'm briefly going to cover our existing guidance and its application, a few reflections from current practice, and then briefly where we might be going next. So in a nutshell, these are the current requirements. This is taken from the Scottish EIA planning regs, but it's reflected in the suite of EIA regs for all projects. So you'll see similar for energy and transport. You can obviously read this for yourself, but yeah, just to reiterate that the regs require a description of the likely significant effects of the development on the environment resulting from, amongst other things, the impact of the project on climate, for example, the nature and magnitude of greenhouse gas emissions, and also the vulnerability of the project to climate change. So starting with the adaptation and resilience component. So this is our current guidance. I was fortunate enough to have an opportunity to be involved in the update. It was first produced in 2015. So as Lewis said earlier, this is nothing new. We should all have been doing this for 10 years already and getting better at it. So first version produced in 2015, and that was following implementation of the 2014 updated EIA directive, which introduced a number of new topics, and climate change was one of these. So I was fortunate to be involved in the update in 2020, which was to reflect lessons learned from emerging practice. We're keen that these guides stay practical. So this is available to everyone, and yeah, I can certainly, I don't think I put the links in this presentation, but I can put them in the chat or make them available. Just a note, some of you might be aware, we're not IEMA anymore, we're ISEP, so we've just been rebranded as the Institute for Sustainability and Environmental Professionals, just really reflecting that the Institute now has a wider remit. Anyway, so this guidance says there are two considerations in relation to resilience and adaptation. The first is the vulnerability of the project to climate change. So this is project resilience, and the guidance advocates a risk assessment type process rather than a more traditional EIA determination of significance. So again, something that's been done is already established practice. We're not trying to overcomplicate it by trying to squeeze this into an EIA format where it doesn't work. And importantly, we need to look at any implications of climate change for the predicted impacts of the project as assessed by the other topic specialists. And these are known as in combination climate effects. For example, could climate change mean that a non-significant effect on water availability in 2024, if that's already been considered last year or this year, it might not be significant now, but could that be significant in 2044? And if so, it's important that we look at that and consider that properly. So just some key principles of the guidance, and this is all, it's quite nice to speak after everybody else because it's very much consistent with what everybody else has been saying. We should be adopting a design-led approach rather than leaving it to the end of line mitigation, and we should be precautionary. So that the guidance recommends, if anybody's familiar with the emission scenarios which are in the Met Office climate projections, we should be using the highest one, which is RCP 8.5, unless there's a good reason not to. And your EIA report, as they're known in Scotland, environmental statement elsewhere, should include a clear characterisation of what the future climate's going to be in your report. And importantly, we should include extreme events. Now, these may be less certain, but as we know, sadly, ourselves, they can often do the most damage. We shouldn't be ruling out effects occurring at the construction stage. As you'll be familiar with the EIA, we often have construction stage, operation decommissioning, and there has been a tendency to say, oh, well, we don't need to worry about construction. Well, we do, because we need to adapt now. It's not all about what's going to happen in the future. So the guidance states that if the project could be affected by climate change impacts or extreme weather events to such an extent that the project was potentially no longer viable, then the design should be changed or the project stopped. So this is really the equivalent of your likely significant effect when we're looking at EIA and considering climate change. So just to end this very brief look at the adaptation element, some thoughts on current practice. So project resilience, some of it we're already doing pretty well. We're already pretty good at considering flooding in planning an EIA, accepting it is a very challenging issue. We're also not bad at considering extreme events in some cases. Projects such as wind farms have to be designed so that the wind turbines will can cope with the strong winds, and there's a lot of good health and safety legislation. Some things perhaps we're not as good at looking at yet are issues such as water scarcity and wildfires, which sadly we've seen again in Scotland this summer. And importantly, when you've got a project where it says that a critical mitigation or enhancement component of the project is planting, we need to make sure that it's resilient to climate change, because there's no point in putting huge effort into looking, for example, at biodiversity net gain if the planting's not going to be resilient to climate change. Overheating, again, very much in the news over this summer. And we're starting to see applications in the UK which are refused due to concerns over overheating, which this suggests that we're maybe not giving sufficient consideration to overheating in EIA. And the in combination climate effects, well, basically, how can you not? It's nonsensical. How can you deliver an accurate assessment of environmental effects over the lifetime of a project if you don't take account of climate change? So you have to do it. It'd be very easy to just have a quick glance and say, oh, well, that effect when you're doing your scoping, it's not really going to be affected by climate change. But we advocate that you shouldn't be too quick to say, oh, it's not going to be an issue. You know, just hold that. Just wait till you've got your first assessment of what all your effects are likely to be, and then have a look and then think, could these be exacerbated or possibly even improved as a consequence of likely climate change? But also, there's no need to overcomplicate it. We don't need to look at really detailed projections. We just really need to think, is it going to be wetter? Is it going to be warmer? Is it many more extreme events? Because that's probably enough of a broad trend to consider this. We also don't need to reinvent the wheel. There's lots of existing good guidance on how receptors will be affected by climate change. We don't have to work this out for ourselves. For example, Historic Environment Scotland has got guidance on how historic environment assets are likely to be affected by climate change. So we don't have to try and work this out for ourselves. So yeah, turning now onto the climate change mitigations and the emissions reduction. So again, we have a guidance document that is available, and I'll make sure that that you have the link for this. And again, I was fortunate enough to be involved in the update of this. So the first edition. So again, this is nothing new. This is something we should have been not quite 10 years, but something that we've had the guidance nearly that long. So we should all be doing this already. The first edition was 2017 and the second edition was early 2022, and we're actually looking at the moment at further refresh to reflect more recent case law and some of the issues we still think that we're kind of struggling with as practitioners, which I will touch on briefly as we go through these few slides. So the principles of the guidance, really, all projects contribute to climate change. It's the largest interrelated cumulative effect. It's EIA language, I know. Greenhouse gas emissions should always be considered and reported, but at varying degrees of detail depending on the project. Remembering this is just here, we're just talking about EIA projects only. We should focus on a proportionate assessment to avoid undue burden. And a life cycle type approach should be adopted, considering pre-construction, construction, operation, decommissioning. Now, those 2 points can, on the face of it, seem to be difficult to deliver on something that's both proportionate and a life cycle approach. But as we've seen, particularly from Lewis, you know, this work's being done already, and you know, it can be done with relative ease. It's not something we should be too afraid of. So the fact that it refers to, again, it's saying use a life cycle approach. Don't try and do something completely different for EIA. Squeeze it into the EIA process and make it different from what people are doing for other types of projects. And again, mitigation, good EIA principle, it should be embedded throughout the project life, with the earlier the better. So just, I don't want to get too into the nitty-gritty of EIA, but this is one of the main reasons for updating the guidance, because it was causing a bit of confusion, and for good reason. The first version said that all greenhouse gas emissions are potentially significant, as we're so close to scientifically established environmental thresholds of harm. And whilst that is true, it did cause problems because people were like, well, I don't really know. You know, so you don't need to do any work. You're just saying that all projects are going to have a significant effect, and that's going to feed through into your application, and then your planning officers are going to have to deal with, well, we've got this significant effect. You know, we're not really sure what to do with it and what account to take of it in the decision-making process. So that's now been revised to say the crux of significance is not whether a project emits greenhouse gas emissions, nor even the magnitude of the emissions alone, but whether it contributes to reducing greenhouse gas emissions relative to a comparable baseline that's consistent with a trajectory towards net zero by 2050. So this is our real test now. I won't read out the 4 different, these aren't set in stone, but these are 4 kind of guides. And you'll see that that you'll kind of you'll get a trigger of a significant adverse effect if a project, can't demonstrate that it's following. It's basically following business as usual. It's doing minimum. It's not convincingly trying to demonstrate that it's compatible with the net zero trajectory. Having said that, it's still a bit tricky, because what is that consistency? How do you tell? To demonstrate that, do you always need number crunching? And then when you do crunch your numbers, what does that mean? How can you compare that? So I'm just going to a couple of slides on that. So yeah, the number crunching. Whilst EIA guidance does say that in some cases a qualitative approach may be sufficient for an EIA project, it does say that for the majority of EIA projects, which are by default, if you've got that far, of a large size, relatively large size, then efforts should be made to quantify emissions. But often this will not need to be done as part of the EIA specifically, because it will be needed to meet other planning policy and to draw on and to meet other regulations. So yeah, apologies, this is an English example. But it was one that I was involved in, interesting, and as I'm sure you're aware, quite a controversial project. But you'll see here there was a whole suite of other documents that had to be produced: an energy statement, sustainability statement, there was a travel plan, there was a whole life carbon statement. So the EIA was not trying to reinvent the wheel. It was also not trying to duplicate, because you only need to read these things once, but it was a useful distillation of the kind of key facts that were in all these documents, which were quite lengthy and quite complex. It was a way of distilling this, setting it out against the adaptation stuff, and just considering what it meant when you looked at the test of significance in EIA terms, when you look at all the other topics. So where are you most likely to get these other documents? Say if there's planning policy or other regulation that requires it, which increasingly we're seeing. I mean, in this example, it's because the London plan will require a whole life cycle assessment for development proposals that go to the mayor, and it's also encouraged for major non-referable developments. So they existed. This is just some research. It's a bit dated now. It was done in 2018, but if anybody was interested, this is the whole kind of issue of how we cover greenhouse gas emissions in EIA. Has been considered in Scotland for a while now, and this was research that we were fortunate to be commissioned to do. It also looked at how greenhouse gas emissions were covered in SEA. So whilst it's a bit dated now, if anybody does want to have a look, they will find it on the Climate Exchange website. And I did still want to mention it because there was still some useful points that came out of it that apply today. So the research found that there are some standard tools. You may know of the wind farm carbon calculator, and there's a tool that's already used for highways projects. So these are transferable if we need to. And obviously Lewis has spoken particularly about embodied carbon and the buildings and infrastructure. So a lot of the tools are there. Again, that the emissions were most likely to be calculated where the number crunching was already done. So again, it comes back to this. If you think, well, I have no idea for this EIA project what the carbon emissions are going to be. As Lewis said, somebody else has probably already done that number crunching, and then it's a relatively straightforward job to convert that into carbon. So the example that Lewis mentioned, for example, your quantity surveyor may know a rough estimate, which is sufficient at this stage, got to be realistic, of the number of bricks and the iron girders needed. And also in terms of transport, you'll have the transport movements. It's a best guess of what the transport movements are associated with that development at all its stages. And again, that can be converted. And finally, there was concern raised about access to expertise in local authorities so that they can advise on the requirements and they can review the information provided. And obviously today's webinar and the production of the guidance is not the whole answer to that, but it's very much part of the process of responding to that. In terms of current practice, just how are we doing? You'll know that embedded mitigation you can take account of before you do your assessment of effects, and it's a bit ropey in some cases for our climate change mitigation because, as an example, some of the government's technology-based approach to addressing carbon emissions are fairly aspirational. But we need to be careful if we're going to be saying that we don't need to worry about airport expansions because all flights will soon be running on sustainable aviation fuel. That would be your embedded mitigation. I'm not saying people are necessarily doing that, but that's, that is a possibility. There's we have national carbon budgets, they're very helpful, but there's a tendency to say, well, it's less than 1%. Well, most projects, if not all projects, are going to be a tiny part of that national budget. So it's not very helpful to say that, yeah, this is on consistent with net zero because it's a tiny part of the national budget, because that's a bit nonsensical. If we don't have really good localized carbon budgets, then we should be looking at more meaningful guidance on how the project stacks up against what's required to meet net zero. And that might be looking at sectoral guidance for that particular type of project. It might be and that's our job as EIA practitioners to do this convincingly, not for those that are determining the applications, but to look elsewhere at what advice is available, for example, from the Committee on Climate Change, the Intergovernmental Panel on Climate Change about anything that's relevant to these projects and how they can meet net zero. Briefly, I won't go through this emerging case law, but we are starting to see some, and the references are here if you want to look them up. The first one was Southampton Airport, cumulative effects of greenhouse gas emissions in combination with other projects. Second one, another airport. This was Bristol. This was a failure to deal with the non-CO2. And the third one, which Lewis has already mentioned, which is the most well-known, is that the Finch case, and how do we define indirect effects. A long-running case, but ultimately it was tight, but it was just judged that yes, we should be considering indirect effects. So in this case, if you're drilling for a new oil well, you do need to consider the future use, so the fact that the fuel combustion emissions. And this is my last slide. So where next do we need to go as EIA practitioners? We do need to improve on inconsistency in practice. We've been at this for 10 years now. We have some good examples and some less good examples. We need to just get that consistency better. We need to get better at quantifying emissions, and we need to get better at looking at how compatible it is with net zero, so we can be say something more meaningful about significance. And I've covered these 2 points in previous slides. It is possible for us to do this. It's not something we should be scared to do, and perhaps not something to dwell on for today, but something we're very mindful of is the UK government's proposal to replace EIA with environmental outcome reporting. We're still awaiting a roadmap. It is meant to streamline and make planning simpler. Again, not the place really to debate that, but interestingly, the devolved administrations may or may not go down this route, but climate change is not one of the topics that's included on the list of topics that should be in an environmental outcome report, because the arguments being that it's not directly or effectively measurable, which isn't quite true, and it's most effectively addressed through strong legislation policy, which arguably applies to some of the other topics. So again, not for big debate today, but something as a practitioner we're keeping an eye on, because we may be dealing with different systems in different places as we go forward. And yeah, that's me. Thank you.
Thank you, Charlie. So my name is Pelin, and my colleague Jonathan McQuillan here. So we'll be talking about a case study we have done for Renfrewshire Council with our tool balance, and we will go through the case study, how we applied our approach, and how it is relevant to NPF4 policy 2 guidance actually. So this is us. We're working at ADC under circumstances. So we will start with what is balance, our tool, what is it included, and we will show a video about it, and then we'll move to NPF4, how it is relevant to policy 2, and then after that we will talk about Paisley Grammar School that we commissioned from Verture Council, how we applied our approach in order to estimate lifetime emissions, operational and embodied, and how we reduce carbon emissions with our place-based strategies. And then we'll talk about place-based sequestration for carbon balance. Then at the end, we'll talk about key findings and what we are doing actually at the moment. So we will show a video.
Anderson Bell Christie is an employee-owned architecture and urban design practice, and together with Scottish Enterprise and Innovate UK, our research has found that embodied carbon in new buildings can be significantly reduced, allowing us to achieve a carbon balance in the places we live.
By 2050, embodied carbon will represent all of the carbon in a new home. This is the major issue faced by the construction industry, and we need to tackle it now. We need to move beyond guidance and legislate. We need a clear plan for the Scottish construction industry.
Our life cycle research tells us we need to make fundamental changes. The construction industry must become truly circular, where deconstruction will likely become a new industry that provides a supply of regraded material to the construction sector.
Alongside circular construction, we need to implement a significant greening of our built environment. Urban greening removes carbon from the atmosphere while protecting the places we live from excess heat and flooding. This will not only make the places where we live more natural and resilient to climate change, but healthier and happier too.
Anderson Bell Christie have developed roadmaps to show how we can achieve these goals. This legislation will need to be implemented quickly. Our next generation of buildings are currently under construction. We hope this research is a call to action that will deliver the transformation we need across construction and urban planning.
To enable the roadmap, we have embodied this change. To do this, Anderson Bell Christie now offer the additional service, Balance. Through this, we can calculate embodied carbon through life cycle analysis, calculate sequestration for street tree and forestry conditions. We have Building with Nature accreditation, and use all of this to provide place-based net zero urban planning.
So I'll just pick up from the video. Unfortunately, you guys couldn't see that, but essentially, Balance was a tool that we created to specifically address NPF4 and the vision that was set out within NPF4. Whenever the NPF4 Policy 2 guidance came out recently, it was really great to see that actually everything that we'd planned was built into that guidance. So we've just created a brief table to explain that climate mitigation is at the core of what we do about greenhouse gas emissions, and we use the PAS 2080 that's been mentioned by Lewis and others. Climate adaptation is absolutely fundamental, and we're place-based in our approach. Life cycle emissions, so that refers to embodied carbon. So we are looking at that. That is again central to the approach, and we're using the RICS methodology. Place-based planning, so yes, local development plans are central to what we're looking at, and actually delivering tangible change in the places where people live and within our communities. Circular economy is fundamental to this, and it's good to see that there's recognition of that within NPF4. And carbon sequestration, so driving biodiversity through things like nature-based solutions and blue-green infrastructure. Again, detailed sequestration modelling is built into the tool that we have developed. So we were asked by Verture Council to apply the Balance tool to their design for Paisley Grammar School. So this is a new build school, and it's just gone through the planning system. It's headed towards site. It's a passive house school, and it's been designed exceptionally rigorously by the design team to achieve very low levels of embodied carbon. So they really have gone above and beyond, and even looked at sourcing steel from UK-based electric arc furnaces and things like that to really drive down the embodied carbon. But even with that, you'll see the scale of the challenge that we face. So the school itself is in Paisley, and it's got quite a large catchment area. It's got a large school. and it's off centre now within its catchment area, moving from the previous school, which was centralised in the catchment. And the first thing we did through the balance tool was to calculate the amount of carbon. So like the previous presenters have explained, there are tools and methods available. And whenever we bring them together and use them holistically, we can actually calculate and get numbers on the amount of carbon associated with different aspects of the design. So through this, the first thing we calculated was the operational carbon. So operational is basically in use. And we calculated this over a 60-year window. And so we looked at the energy that the school will use, but we also looked at things such as how much waste will be generated from the school, water consumption, street lighting, and maintaining the green spaces to get a holistic overview on what the operational carbon would be over a 60-year window. We also then calculated the embodied carbon, and we calculated that across all life cycle stages. And what we found was that actually the embodied carbon, even after fantastic efforts from the design team, was still triple the operational carbon for the building. So I think at the moment, there's a real focus on how much energy buildings use, but actually that's now, we're well past that point of being the most important thing. Actually, the most important thing now is embodied carbon. And we can see that even despite best efforts, nearly 15,000 tons of carbon emissions will be generated over the 60-year lifespan. So in total, when we add that together across 60 years, a brand new passive house school will emit 19,000 tons of carbon over 60 years. So what do we do with that? Now that we have that number, what on earth does it mean? So what we've been looking at is actually how we address carbon within a place. And in order to get that balance, we've been using tools such as the Woodland Carbon Code and iTree, and we're able to calculate the amount of woodland, for example, that would be needed to sequester the carbon over that period. So for the same 60-year window, you would need to plant 43 hectares of woodland to sequester the carbon from that school. So we then looked at strategies that could reduce the carbon and therefore reduce the amount of sequestration required. So on the operational side of things, we looked at well, what would happen if we really enhanced the active travel solution, because the school was moving within its catchment area, and actually how do we capture all of the different population centres that will be within that catchment area, and how do they get to the school easily, and what does that mean from a carbon perspective? We looked at what would happen when we reduce the number of private cars that are burning diesel or petrol, and we also looked to see what would happen if we did more rapid electrification of the public transport fleet. And altogether, those carbon savings generated a reduction in the woodland that we'd have to plant of around 1.5 hectares. And we then ran this similar exercise on embodied carbon, and we looked at a whole variety of different options for, what would happen if we change the building form, what happens if we then swap out materials, so we use different ground floor, upper floor structure, internal walls, external walls, etc. And what we found was that actually the biggest savings available were actually in the embodied carbon. So the savings generated there would yield a further woodland reduction of about 5.7 hectares. So that's quite significant. But you'll see together, it's still not enough. But what we would say is that I think the positive side of things, and I think the thing that's really important about the message from today, is that we have to start now. We have to start looking at these things, and we can do this. We do have the tools. We can reduce carbon, so we now know actually how to do this, and we can do it holistically across a place. And we can also sequester locally, so we can now also calculate the amount of carbon that we can remove from the atmosphere within a place, and in doing so, provide the benefits of that planting within a place. So that will help control urban heat island effects, and it'll help mitigate flooding, it'll help with improving biodiversity and health and well-being, various other benefits in the places we live. And that could be achieved simply within the spaces between our buildings. So for example, if we take these active travel routes, and if we create the active travel route that we're considering for Paisley associated with the school, but we green it, then all of a sudden we can do a lot more within the spaces that already exist or will be created. And our key findings are that really embodied carbon is currently the biggest challenge. We can't tackle it all immediately, but we can tackle it over time. And we think it's important that we start now, because we have to build a general understanding of embodied carbon to then know how to tackle it. And what our research has shown is that as we move towards 2045, we need to be moving to a circular construction position, because that's how we make the big savings in embodied carbon. And whenever we do that and get to a circular position, we believe that Scotland in the mainstream could achieve 150 kilograms of carbon emissions per metre squared. So there still is residual carbon that we have to deal with, even when we make circular construction the mainstream approach. But we need to get there, because otherwise it becomes challenging to address carbon in embodied carbon. But whenever we do that, when we get to the 150, actually where we get to is we can reduce the amount of woodland associated with the embodied carbon down by 22 hectares. So we're coming down to actually what is really quite small and very manageable amounts of woodland in the grand scheme of things across a local authority. So all of our work that we've done on this is in a white paper. The white paper is summarized in the video, which unfortunately you couldn't hear the audio. The video is also available on our website. We've got a dedicated website for the white paper. That's balance.andersonbellchristie.com. And we're also presenting the white paper to the Scottish Government. We've been asked to attend a cross-party working group for construction, nature and circular economy in October. So it'll be really good to present a holistic approach to place-based net zero. And I'll just hand over to Pelin, who'll tell you a wee bit more about some of the future work that we'll be doing.
So whereas we are taking this work is we are currently looking at Montrose at Angus Council as a pilot to determine what net zero local development plan would actually look like. And so we are applying the principles of balance and taking out these data, policy plans, and amalgamating that to see how a net zero LDP will look like. And we will be presenting the findings of this work at RTPI conference in September next month. Yeah, and that's it.
Yeah, so thanks very much for listening.